Okay, in this video we're going to be sketching trigonometric functions, essentially transforming, doing some function transformations. Now for each function we're going to have to collect each of these pieces of information: the period, the amplitude, the equation of axes, max and min. And each question will be in this format. Okay, so let's begin with our example. With our first example, we have y equals 6 sine, open bracket, 3 times x minus 20 degrees, close bracket, close the square bracket, plus 1. Okay, so first let's start collecting our data. Let's collect what seems to be more obvious here. So the amplitude will be 6. The equation of axes, hopefully you guys can see this. The equation of axes will be 1, so we write it as y equals 1. Okay, the value of d will be, well, there's a shift to the right by 20 degrees. So that means d is equal to 20 degrees. And the period, now remember that the period is equal to 360 degrees divided by k, and k happens to be 3, so we put it here. So p equals 360 degrees divided by 3 gives us 120 degrees. Okay, and last but not least, let's collect the maximum and the minimum values. So the maximum value will be c plus a, which gives us 7, and the minimum value would be c minus a, which gives us, in this case, minus 5. All right. Okay, now I think we've got everything that we need in order to graph this. Now remember that all this thing is in degrees, so make sure your calculators are in degrees when you use them. And now you could use the mapping rule. I'll let you figure that out on your own, how to use the mapping rule, but this method is much faster and better, and it's a sketch, so it shows the key points. So if I ask you a question like this, I want you to show me all your work, and I want you to show me all the key points. So first I suggest we start with this value, with the value of d. In other words, with the value where the function has shifted. So in this case it has shifted 20 degrees to the right. So we do this. We do a dotted line here indicating this will be 20 degrees. And the equation of axes here happens to be 1. So 20 degrees. Hopefully you guys can see that. Let me see if I can get a shot of that. Yes. Okay, and then the equation of axes is at 1. So also a dotted line like this. And at the end label it as y equals 1. And also let's collect the maximum and the minimum values. So the maximum value will be 7 and the minimum value will be -5. Okay, and of course halfway in between here, this is the 1. Now if the equation is this one, y equals 6 sine, open bracket, etc., etc., we got to ask ourselves, what would be the base function, what would be the parent function for this one? And I would say that the parent function for this one would be y equals sine x. So what you can do is, and you can have it as a reference here, I should have done this at the beginning, y equals sine x, so this is our base function. And how does y equals sine x look like? So just do a rough sketch of this, and you guys should know this by heart. It starts at 0, positive 1, negative 1. It starts at 0, it goes up, and then it goes down, and then it goes up again, back to the axis. And it takes 360 degrees to complete one cycle. 180. And then halfway between these will be 90, and halfway between this 270, of course. So have this is the base function. Have this as a reference. So this means this is our base function. This means we're going to use this as a reference when we graph our transformed function. So now let's go back to this. So now we know we start at 20. We know that the period here is 120 degrees. So if we start at 20, and the period is 120 degrees, that means we're going to end up at 140. So roughly, once again, this would be our 140 mark. Okay, this will be our 140 degrees. So now the period from here to here is 120, so let's divide this in 4 parts. So halfway between these 2 points is whatever that's going to be. We're going to figure it out in a second. Halfway between these two and halfway between these two. So we have 4 parts. 1, 2, 3, 4. Okay. So yeah, from here to there is 120 degrees. So halfway of the period of 120 will be 60, so 20 plus 60, so this halfway point will be 80 degrees. So you can label it there as 80 degrees. And if it's 60 between these 2 points, halfway, this one would be 50 degrees, right? And another 30 here going that way would be 110 degrees. Okay, we've got everything, and now we know that our base function is this one, and this one starts at 0. So for us here, after it's being transformed, we're going to start at that point, at the equation of axes, and then we go up, and then we go down that way. Once again, it's a sketch. Then we go down this way to the lowest point, and then we end up there, right? And then you join all these with a smooth curve. Okay, now once again, I should have done this more or less like there. Yeah, maybe I can fix this little point here. Anyways, that's how you sketch this. And then, so this is what I'm looking for. You're showing all the key points, showing the equation of axes, you're showing those, you're showing the max, you show the minimum point, and you know, you may be wondering, okay, where are the actual x-axes? You know, y equals 0, x equals 0. So always like kind of eyeball it, right? If this is 1, you know, 1, 0, negative 1, 2, so I would say 0, our 0 axis is roughly there. If you really want to graph it, you can graph this at the end. And if from there to there is 30, maybe 2/3 of the way going this way, that will be our x-axis as well. So that's it. This would be our 0, and that's our max, that's our min, and that's it. And this didn't come out quite as those. Actually, more or less it did. Okay, so that's it. That's how you graph these.